Hey, statistics people. We're going to be looking at our free response questions from our Chapter 4 practice test now. So strap in and let's get going with our free response questions, Chapter 4. Number 1. A petition with 500 signatures is submitted to the school principal. The principal would like to check the petition for unregistered names and fake names. So there's not enough time to check the entire list. So describe how to create a random sample. It's just a sample, but I imagine we want a random sample of those 30 signatures. So remember, there are three things that we need to do to create a simple random sample. We want to label, we want to randomize, and we want to select. So what do I mean by label? Well, that's pretty easy. We're just going to number each signature on the list from 1 to 500. Randomize. Okay, let's use a spreadsheet or a TI-84 to create a randomized list of numbers from 1 to 500. So this means to us that we have two lists here. One list of 1 to 500 with the names attached to the names, and another list of just random digits between 1 and 500. They come together in the selection process. The signatures in the petition that correspond with the first 30 numbers in the randomized list are going to comprise a sample. So if the randomized list, if the first number is 31, then we're going to go to the signature list and find the 31st signature, and we're going to check that one. If the second number on our randomized list is, say, number 481, then we're going to go all the way to the 481 signature, and we're going to check that one. So we need to check the first 30 numbers that appear in our randomized list of 1 to 500. So we're on our way. Number 2. The size of the tip that the waiter receives is determined by the server's behavior, for the most part. In an experiment, a waiter would flip a coin to determine whether he would stand or squat next to the table. The waiter would then record the amount of the bill and the tip received and whether he stood or squatted. So let's figure out what is the treatment and what are the response variables. So the treatment is whatever he did to in this case, the tables. So what did he do to the tables? Well, for this experiment, he either stood or he squatted. So the treatment is the waiter behavior. Treatment 1, stand next to the table. Treatment 2, squat next to the table. Response variable, it looks like we are measuring two things. One of them is the tip received, and the other one is going to be the amount of the bill. How about extraneous factors? What are some other things that could affect the size of the bill? And can we control those? Well, I'm going to pick on the time of the day for the rest of this assignment, or the rest of this problem, because I think the time of the day is probably going to affect the size of the tip the most. So we're saying that the time of the day could be that extraneous factor that affects the amount of the tip. If we set a specific time of day to conduct this experiment, then we have a way of controlling that extraneous factor. So for example, you could only do this experiment during the lunchtime crowd. Likewise, you could probably just do it for the dinner crowd as well. But either way, you're controlling when you're doing this experiment, or you're controlling which subjects get admitted into this experiment. Blocking. Well, if the time of day affects a tip like we thought it would, we could block this experiment by time of day. So here's the example that I set up. Let's say that we only select 10 customers from the lunch shift. Naturally, they'd be randomly selected. And then we're going to also only randomly select 10 customers from the evening shift. 5 of the customers in the lunch shift will get the standing behavior. 5 of the customers in the evening shift will get the standing behavior. Likewise, 5 customers from the lunch shift are going to get the squatting behavior, and 5 from the evening shift will also get the squatting behavior. I said behavior, but really we should be calling them treatments. So those treatments will be applied to 5 customers in the lunch shift and 5 customers in the evening shift. So that's going to ensure that your sample will have an equal number of experimental units from both shift, so that if there is a difference, and we're saying that there is, if the time of day does affect the amount of the tip, then we're going to minimize this effect by controlling how much customers we admit from the lunch shift and how many customers we admit in the evening shift. So that is our blocking. Okay, blocking is just making sure that we have so many from this category and so many from this category to make sure that we, if there's a confounding variable associated with those categories, we can, make sure that we don't overload with one or more of those categories. Hope that makes sense to you. Confounding variables. What is the role of randomization? Well, let's just get a list of confounding variables. Well, here's a few. Time of day. We already talked about that. I said I was going to pick on that, so I am picking on that. Here's another one. The size of the table. The size of the tip on a table with 20 people is definitely going to be less than the size of the tip from, a couple's table. Here's another one, the average age of the table. It's known that some age groups tip differently than other age groups. So that's another thing which is a confounding variable. It affects the size of the tip. Finally, the role of randomization, and this is really a set answer for this. It's a definition. Why do we randomize? And there are 2 things here that are why we randomize. The first one is that in terms of experimental design, the randomization is going to take those confounding variables that we don't know about and hopefully distribute them equally among the treatment groups, so that no one treatment group has a lot of that confounding variable. Okay, so minimizes the effect of confounding variables. Number 2, if we do use randomization, then that's going to allow us to deduce a cause and effect relationship, because everything else being equal, the only thing that's different between multiple groups is this one treatment, then that treatment has to be the thing causing the response variable to react as it does. So next, let's take a look at Pismo Beach. I don't know if you're from California or not, if you're watching this. If you're in my class, obviously, you've probably heard of Pismo Beach. But Pismo Beach holds an annual clam chowder contest. Can confirm they actually do have a clam chowder contest. So the judges are going to rate the clam chowder from local restaurants, and then one year, to the shock of everybody, Denny's was the winner. Denny's, the roadside diner, I guess that's the best way to describe them. They were the winner over all the other local restaurants. So that kind of shocked people. Part A. The judges of the clam chowder participated in a blind testing. What exactly does that mean? Now, in terms of just definition, a blind experiment means that the subjects don't know which treatment they're going to receive. In terms of this clam chowder contest, this meant that the judges didn't know which clam chowder they were sampling. And that's probably a good idea, because there is some kind of prejudice based on the name and reputation of the restaurant. So, do you think that the Denny's would have won if the judges were not blind? I think I answered that question just now. Most likely not. The judges probably would have known about Denny's reputation as not really a high-end restaurant, and they probably would have judged Denny's clam chowder, like it wasn't a high-end restaurant. So there would have been some prejudice there. And then finally, looking at this very last free response question, we've got high blood pressure adds to the workload of the heart and arteries and may increase the risk of heart attacks. If not treated, this condition can also lead to heart failure, kidney failure, or stroke. So we want to test the effectiveness of some, and excuse me if I say this wrong, angiotensin converting enzyme, ACE inhibitors, as a treatment for blood pressure. So it's well known that men and women react differently to common cardiovascular drug treatments. So what sort of treatment would you choose for this study, knowing that, and why? Well, if you know about a confounding variable and you are not able to control for that variable, then there's really only one thing for you to do. We want to use a randomized block design. Now, the block design is going to minimize the effects of the confounding variable caused by gender, or the confounding variable gender, if, of course, we make our blocks based upon gender. So what's going to happen here is we're going to make sure that the number of men who are in treatment group 1 with the ACE inhibitor is the same as the number of men in treatment group 2, placebo. Likewise with women, the same number of women will be assigned to the ACE inhibitor as are assigned to the placebo group. Remember, placebo is still a treatment, even though there is no treatment. It is still a treatment group. Okay. B. Explain why an experiment using 600 men and 500 women is preferable to the one involving 60 men and 50 women. This is just an experiment that has to do with, this question really is about sample size. Big sample sizes are always better. So this is the experimental design principle of replication at work. Large samples will always have the effect of lessening the random variation due to confounding variables. Because if you do have a confounding variable in your group, say you have one outlier observation in your group, then having a large sample has the effect of averaging that outlier with the rest of the observations. So it increases our ability to distinguish the effects of the treatment. So we're more sure that if there is an effect, if there is a difference in our response variable, we're more sure that that difference came because of our treatments rather than from random variation. Lastly, assume that the 600 men and 500 women suffering from high blood pressure are available for the study. To describe an experiment and be sure to include a description of how you would assign individuals to the treatment groups. So really, this is just the same thing that we've been practicing for. We have a number of steps to go through. Let me get them for you. So we need to do 4 things here. We want to, first of all, describe the experimental units. And that's usually just a very rough description. Next thing is to randomize into groups. And we're going to be using a blocking design. So we're going to talk about that. And then we want to have a treatment description for each group. And then we're going to talk about what we're going to compare. So let's see. Who are our experimental units? And it's just the 600 men and 500 women that are available for the study. Now, this is an experiment with people, so we're going to call them subjects. Got to humanize them a little bit here. Okay? And remember that when you do this, you're not meant to expand beyond this. You're not supposed to say, well, there are 600 men, but I want to get 1,000 men, so I'm going to find 400 more men. That's just making your life too difficult. This is an academic class, and you want to stick to the way the question is written when it is, or pretty much at all times, unless there's some glaring mistake. Assuming that this isn't a glaring mistake, and it's just nothing wrong with the way that this is written, don't go beyond the 600 men and 500 women, and don't use less than the 600 and 500. They put those numbers there for a reason. So, next we're going to randomize into groups. Because this is a block experiment, we're going to talk about the first block, and then we're going to, suggest that we repeat it for the second block. So our first block is going to be the men. Now, if you're in my class, you know that you have these wonderful sentence starters to help you through this. So I've just gone and copied and pasted what we have, and we're going to just adjust it to our experiment. So we're going to use a calculator or spreadsheet like Google Sheets or Excel to assign each experimental unit a random number. Now, remember, this is different because we're not making a sample. We're designing an experiment. I forgot. We need to start with the men. Start with the men. Okay. Use a calculator to assign each experimental unit. They're men. Each man. A random number between, there are 600 men, so we're going to give them a number between 1 and 600. Okay, with no repeats. The experimental units, again, we got to humanize this. We got to make this tailored to our experiment. So the men that receive numbers from 1 to 300, that's half of the men, are going to be assigned to group 2. And then there's only group 1, and there's only 2 groups, so let's see, 301 to 600 are going to be assigned to group 2. Continue as necessary. Well, we don't have to continue. Okay. For now, we have to repeat this for the women. We're going to repeat this process for women, and we're going to assign 1 to 250 to group 1 and 251 to 500 to group 2. Now we have to talk about the treatment description for each group. Okay, another copy and paste job from our list of sentence starters. And group 1 will receive treatment 1, and treatment 1 is, of course, the ACE inhibitor. Okay, and there's only 2 groups, so I'll put the word "and" here. And group 2 will receive treatment 2, which I believe is our placebo. Okay, and there are no other treatments, so we'll just stop it here. Okay, so that ensures that half of the men are going to get the ACE inhibitor, and only half of the women are going to receive the ACE inhibitor. Likewise, only half of the men, or exactly half the men, are going to receive the placebo. Exactly half the women are going to receive the placebo. Okay, compare. What are we going to compare? Well, we're going to compare the average blood pressure, right? So at the end of our prescribed time, we're going to compare the average blood pressure from group 1 with the average blood pressure from group 2. So we described our units. We randomized into groups. We described the treatment for each group. And then we gave an idea about what to compare at the end of the experiment. And that's our experimental design. So that's the end of this. That's all of our practice test for experimental design. Hopefully you found this useful to you. If you don't have those sentence starters for your class, particular class, if you're not in my class, then you're going to want to pause it over and maybe jot those down. They're really good for you to have. The other thing that I could think about is make sure you get some kind of experience in describing experiments on all 4 types of experimental designs that we do in AP Stats. You've got the comparative block design that we did in our experiment, but you've also got the randomized, completely randomized experiment. You've got a match pair with similar groups, and you've also got the match pair with own control. So make sure you have some kind of instance for all 4 of those experimental design types. And good luck to you on your Chapter 4 test, and have a great day. See you next time.